So in exercise 6b, we're going to now look at integration. Just a word of warning about the textbook. It goes beyond the concepts of extension 1 here, so we just have to be careful about which questions that we actually going to do. The extension 2 students, I'm not sure whether you're up to how much trig you've done so far, but you will probably, if you've covered it in extension 2, you'd find that you can answer probably most of the questions from this exercise. But like I said, for extension 1, there are questions there that are beyond the content that we need to cover. So although it says the integration of the 6 trig functions, let me just point out the most common ones you'll get. So obviously you know to integrate sine, you get minus cos, so this is not new. Integrating cos, you get sine, and integrating sec squared, you get tan. So I guess we've got 3 trig functions covered there. The integral of tan, now we said the integral of tan was something unusual because tan, we don't know what to differentiate to get tan. So what do we do in that case? We rewrite tan. Tan is sine on cos, and we can see that if we've got the derivative of that function, the function in the denominator, we've got its derivative in the numerator, or likewise the opposite, but that's not going to be helpful. We know that when things will go to the denominator when we take the log. So if we think about the differentiating log of cos goes into the denominator, and then obviously the derivative of cos would be in the numerator, and that's why we've got that the integral of sine on cos, and of course it's negative because differentiating cos, you get negative sine, and we didn't have a negative there, so we've got to put it in the original question, or the original function. Cot is similar, so cot we rewrite as cos on sine, and we can see that that would come from differentiating the log of sine. Sine goes to the denominator because it's a log, and then differentiating sine, you get cos. So they could have been looked at in a combination log trig chapter. Okay, anything else will fit either the category of it could be squared, we're now little detail difference, but something to note. So if it's sine squared x, we've got an expression for sine squared from our identities. It's a half minus a half cos 2x. What's the advantage of that? Well, we know how to integrate a half. We know how to integrate cos 2x. Do we know how to integrate sine squared? No, we don't know what was differentiated to give us sine squared. So the moment you're seeing something sitting here and you're going, well, I don't know what was differentiated to give that, then we've got to be able to rewrite it in some other format. I'm taking the half out from here to here. All I'm doing is taking the half out, which is a good idea. I don't want this all complicated. And then I'm just going to integrate 1, which goes to x, and integrating minus cos 2x is sine 2x on 2. So similarly, the integral of cos squared. Again, I don't know what was being differentiated to give me cos squared. I know it wasn't cos cubed because I'd have to have the derivative of cos somewhere. So straight out cos squared. What is another way I can write cos squared? It's this format, taking the half out, then integrating and keeping the half, integrating 1 goes back to x. Cos 2x came from sine 2x on 2. Tan squared, again, these squareds, because they feature in our identities, we've got another expression for tan squared. And how convenient, we do know how to integrate sec squared. Sec squared came from tan, and 1 comes from x. So the squareds are really quite nice. If If you come up with any other combination like this combination, or the other really good one, and I might do it in a separate video, I think it's question 2E. I'm going to do that, but like I said, I'll do it in a separate video. It's this combination. What are we seeing here? We're seeing that actually this could be the function that I could be adding 1 to the index, dividing by the new index. Why? Because its derivative sits there. So when you see that, hopefully you will recognise that situation, and it is simply that add 1 to the index on sign, divide by that new index, and add the constant. And you can always check, differentiate that, see if you get that as the result. And like I said, I will do question 2E because it's also one where there's a product and a combination of terms, but it's a little bit different to that one. Hopefully you'll be right then to do 6B.